All right. Now we're looking at question 27. This one is about a human cannonball being fired out of a cannon. Cannonball. Okay. Here's what they tell you. There's a time of 1.5 seconds for him to shoot out of the cannon, and the cannon has a distance or a length of 1.6 meters. So that means if you're in a cannon, here's your cannon, right? It's 1.6 meters, and you shoot out of the cannon, you've traveled 1.6 meters in 1.5 seconds. Okay. Then it says the mass of this circus performer or human cannonball is 65 kilograms, and they want you to find the force. Okay. Well, remember, F equals ma, F net, the overall force. Well, in order to do this, we need an A. So we have to go back to look at these things. Actually, not the M. We need to look at these two things and try to figure out if we can get an A from that. So let's just look at those. Let's look at the time of 1.5 seconds and the distance of 1.6 meters. But let's also think about Mr. Cannonball. Here he is sitting in the cannon, and then the cannon fires. Boom! And he shoots out. Which means at first his V1 is just 0. So he has a V1 of 0 because he's waiting to be fired. So we can use that. Then we can say, okay, what about A then? Can I figure out A? Well, there is a way to do this. If you look at these four things and you look back in Unit 1, you'll see D equals V1T plus 1/2 AT squared. So what you have to do here is put in the meters, the 0, A, and the time. I could have put the time in here too. Maybe I should have done that. This way it looks funny. Let me just go back and finish that right. Sometimes I jump steps and I shouldn't do that. So it's 0 times the time of 1.5 plus 1/2 A times 1.5 squared. And you just work that out for A. You just solve that for A. So you want to do 1.6, and then it's 1/2 of A times 1.5 squared. The 0 part we get rid of. So you take your 1.6, and all you have to do is work out the math. So 1.6, we're going to divide by 2, multiply by 2, 1.6, or divide by 1/2, right? Multiply by 2 on both sides, and then divide by 1.5 squared, and you end up with an A of 1.42-ish meters per second squared. Okay? So it's not very fast, but remember, this isn't a speed. This means that this guy's going 1.5 seconds, or 1.42 meters per second faster every second. Okay? It's actually not a very good question because it's not realistic. It wouldn't take you 1.5 seconds to shoot out of this cannon if it's only 1.6 meters long. It would probably take more like 0.03 seconds. So it's not very realistic, but nonetheless, those are the numbers that we have, so that's what we have to go with. Now you can do your F net equals ma. And your F net is the mass, and it told us the mass was 65 kilograms multiplied by our A of 1.42. And when you multiply that together, it's not a very big number. 65 times 1.42, 92-ish, 0.3 newtons. So it's not very realistic, is it? It's a very weak, pathetic cannon. I'm just going to go back and make sure that I got all the numbers right, and it looks like I did. Yep, I'm just double checking the math to make sure, because when you get unrealistic numbers like that, you sometimes go, what? But everything looks good so far. So